Hello friends, this is Durga again from Technology Mentor / IT Varsity, and at this time we are actually talking about adding or decreasing the capacity to the existing cluster. And in this we will be talking about scale in or scale out. Scaling is to decrease the capacity of the cluster by reducing the nodes from the existing cluster, which we will see later. For now, we will be focusing on scale out, which is adding new hosts to the cluster. So these are the high level steps. You have to provision the host, execute the prerequisites, use the wizard to add the host, and then you have to configure. But the configuration steps changes between role of new host, if it is master or slave, and again if it is master, depending upon what technology you are configuring it as master, the steps will vary. So you need to have a deep understanding about the architecture if you are trying to add a new node as a master, and if you want to move a uh, particular master component to this new node. And once it is done, you should validate the cluster by running several map reduce jobs, or if it is master, by taking care of certain things of that particular technology. And once if the slaves are added, the data have to be rearranged so that each and every node in the cluster is load balanced. So data from the existing nodes have to be load balanced on the new nodes to the cluster. So a lot of data have to be moved to the new nodes. When I say data, the blocks associated with files have to be moved to the new nodes, and it can saturate the capacity. So you have to be extremely careful, and even though you can add nodes to the live cluster, running balances should be uh, taken care with care. Otherwise, your network can get saturated and it can cause issues to the existing application. So you have to consider that while after adding the new nodes to the cluster before a balancer runs. So let's go ahead and start. So I am provisioning the nodes in the AWS. So in AWS it is pretty easy. You can choose a particular any of one of the node and click on actions, and then you can say uh, yeah, you can say launch more like this, and then it will automatically take m3.large, which is the existing one. You need to review all these parameters. In this case, if you want to increase the number of instances, typically we will not add instances one by one unless if one of the instance got hardware issue, and if it is decommissioned, then to replace that we might add one instance. But if you genuinely want to add capacity, it could be 10% of the existing cluster, one third of the existing cluster, or 10 nodes, like that. So it depends upon the requirement at that time. And then storage, let me validate how much storage I got. It got only 10, so I'm increasing it to 40 GB as any other node in my cluster, and then review and launch. So I have m3.large. I'm using the security group, so the ports are related to those security group. I'm fine with that. The instance details, I'm only choosing one of them, and uh, then I have increased the storage, and the tag, let me rename it to slave temp. Okay, then review and launch, and click on launch. And I want to use the same PEM key which I have been using earlier, which I have used earlier for the other nodes. And then you can click on view instances, and it will be started in a moment. So automatically it took the public IP because we have subnet configured, and this is not static IP, and whenever I stop and start, this IP will change. So I will leave like that because uh, because for now I'm okay with that. Okay, so let's wait until it starts. Let's note the private IP address for this node. I think it's not there here, so I want to check the private IP. I'm sorry. So for this one, the private IP is IP 10.0.0.179. So let me do this. Yeah, now let me add the private IP also to the list. Private IP address, close, and then I want to sort on the private IP. And our last node is the one which is added just now. Okay, so now you can connect to this through the gateway, because typically we will not use public IPs like this, but I don't care for now. But I will use the way we tend to do when we considering that we only have private IPs but not public IPs. So for that, first if you are using Mac on terminal, because you already have the keychain, you can run this command ssh add -k and then add the pem file which we have used to create our cluster. In this case, this one. If it is Windows, if you have to use Sigwin, and I have covered that elsewhere. You can go to the earlier videos of my playlist and you can get those details. You have to run ssh agent bash. Once you did that, once you get into the SSH agent and launches another bash console, then you have to add the command. You should hit enter, and then you should run ssh add and give the path of your pem file. That is on Sigwin on your Windows laptop. But if you are using Mac, you just have to run this command. To review it, you can just review by running ssh add -l, and it will list whether this key is added or not. So that is for SSH forwarding, because we will have only gateway node with public DNS, and all other nodes will be using only private IPs, and you will not be able to connect directly to them. So you have to go through gateway to the other nodes in the cluster. Now I can do ssh -A ec2 -user at, sorry, I have to give the public DNS of the gateway node. So in this case, my gateway node is this one. I have to give this public key. Hit enter. Now we will be logging into that gateway node with SSH forwarding enabled. Now you can validate SSH ec2 -user. I'm trying to connect to the new node using the private IP. The private IP is 179, IP 10.0.0.179. So here I have to do 10 -0 -179.ec2.internal and hit enter. And you are in. So now we already have parallel SSH. At the time of setting up the cluster on gateway node, we have set up the parallel SSH. So here we will use parallel SSH to set this up. So let me create a new cluster hosts file. So vi cluster new host.txt and enter the IP address, the private IP address of that, 179.ec2.internal. Okay, now we have to run we have to create this script. Actually, that script, if you review that script once again, it will copy our prepare node.sh, which have all the prerequisites that needs to be set up on a given node. So like disabling SELinux, setting umask, changing permissions for the new changing ulimit for new users like HDFS map read on number of process and number of files. So all these things are taken care as part of prepare node.sh. Again, this is covered earlier as part of setting up prerequisites. Same things we need to do it now. And if you look at setup AWS Red Hat, what it is trying to do is it is trying to copy prepare node.sh onto all the hosts that are in this file clusterhost.txt, and then we are trying to run that on all the hosts which are mentioned in this file. So now we have to run this script for our new nodes, and our new nodes are in the new file called cluster new hosts.txt. I have added that to one host, but if you have n number of them, you can add all of them, and then you better to create a copy of this script. Setup AWS Red Hat new hosts.sh, hit enter, va setup. We have to modify the host file name. So our host file name is cluster new hosts. Okay, now you can actually run setup AWS Red Hat new hosts.sh, and okay, the file name is incorrect. Let me see the file name. It's cluster underscore. Let me rename this cluster new hosts with underscores to minus or hyphen. Now let me run the script. Okay, now it is copying the file to the 179 instance, and now it is actually running the prepare node.sh script on that. And once it is done, the server will be rebooted. Until then, we cannot connect to that instance. Once that is done, we will see how to add that instance to our cluster using Ambari. So cluster should have been restarted by now. Let me run ssh command again to validate that I'm able to connect to that node, which is just restarted after setting up the prerequisites. And let's validate. One thing we have done is we have disabled SELinux. For that, you can actually cat on SELinux config file, which is under this location, etc SELinux config, and hit enter, and you can see that it is disabled. Originally it was enabled, but as part of the prepare node script, we have disabled it. Also, there will be a log file here, prepare node.log. You can have a look at that, review that, what have it all done, and whatever you want to validate, you can validate in those. So we have disabled SELinux, set up NTP, and disabled IP tables, and disabled virtual memory swappiness, and also we have changed the file handle limits for new users, which will be created as part of setting up HDP using Ambari. So now let's go ahead and go to Ambari. Make sure our cluster is up and running with all the components we are interested in. And to add the host, you have to click on the hosts, okay, and click on actions, and then you have to click on add new hosts. Here you have to give the host name, which is our private IP, and as I have shown earlier, you can give the patterns also. And then you have to use whatever user you want to use. In AWS, we will be using EC2-user. And if you are using virtual machines, don't attempt on this on your 16 GB laptop. If you have 32 GB, it's a different story. If you have 16 GB, already you have saturated 10 GB for the existing 4-node cluster. If you add one more cluster, your laptop will become completely unstable, and you will see a lot of crashes on the VMs, and it is not productive. So, but you can easily follow this video and understand how it works. So no need to try this on your PC. So I need to get the private key now. So the private key is related to the key pair which I have used. So already I have covered how to get those details in the earlier video. You just need to cat on the PEM file which you have downloaded when you set up the key pair before provisioning the cluster, and then register and confirm. So make sure you have the public IP associated with this, otherwise because of some of the dependencies requires public repositories, it will fail. Yeah, I think it will fail. What we need to do is after doing this, we have to copy our repo files also. So let me do that. So I forgot one step. After setting up the prerequisites, you also have to copy the repo files. So let me add to the PPT. Copy Ambari repo files to use local repositories. And then once you does that, yeah, that's fine. So somewhere it should ask about our repositories. We will see whether it will ask or not. So the way you can copy those repository files, you have to be on the gateway node, and we have the repository files on etc m.repos.d, and you can see this ambari.repo and hdp.repo files. You have to copy these things, scp etc m.repos.d ambari.repo to ec2 minus user at ip minus 10 minus 0 minus 0 minus 179.ec2.internal and home directory. Similarly, we want to copy hdp.repo also. And then we have to do the SSH to that box, because the files have to be under etc m.repos.d, which is owned by root. Using EC2 user, you cannot copy them directly. And now I can copy those two repo files to etc m.repos.d and hit enter. You can do it using sudo, because the EC2 user is by default sudo. Now you can review that we have those two files over there. Okay, now we will go back and click on next. All the checks are passed on this. Then click on next, and we want to set up the data node, which we are trying to add this node as a slave. If it is master, you have to revisit the architecture and make sure you configured with the components you want to be running on it. So I want data node, NFS gateway, node manager, region server. I don't want Phoenix query on this because I have not configured Phoenix query with respect to HBase. Once it is done, you can click on next, and configurations, we will leave all of them as defaults. So this window is new compared to setting up the new cluster. Okay, and once that is done, you can click on review, and even though actually what happened is when we set up the cluster, it has taken this repositories information and it has cached that. So as long as we have the repo files, you don't need to modify at the time of setup. Okay, so just review that it is trying to connect to the local repository, and then you can actually, as it is using the local repository, you can actually click on deploy. It will take a while to set up all the components because there are all these things which needs to be installed, and you can click on this and see what's going on as it progresses. I think there is a bug in Ambari. When we try to add new clusters, it did not let us to not to configure them as client. It is installing clients on all the new hosts, so that's why you see all these things. Probably it could be a bug in Ambari. Instead of just doing data node install, it is also setting up clients on for all the components which we are trying to set up on it. Or this could be normal also. I'm not 100% sure, but even if you have client on all the nodes, as long as you are not running jobs from from those nodes, we are good to go. Now the installation is started. So the setup is done. So it has set up a data node HBase client, region server, HCAT, HDFS, Hive, and many more. And all the slaves that needs to be installed for our ecosystem, what we have as of today, are installed on this. Click OK and then click on next. Click complete. So now we have 7 nodes instead of 6 nodes, and it is showing 15 components because all the clients are also installed. So I think it's a bug in Ambari, but it is okay. Even if we have more all the clients set up, there is no harm in that. As long as we have the data node, region server, and other slaves which needs to be running on that node, we are good to go. That being said, now let us validate whether our files are distributed on that node or not. For that, we have to enable SSH tunneling, and I need to use Chrome for that because I have configured Chrome with Foxy proxy. So SSH tunneling is a 2-step process. One is first you have to do SSH tunneling using command prompt with the -nd option. I have covered this also elsewhere. So once you hit enter, it will hang. That means SSH tunneling is going on. And now I can go to the Chrome, enable Foxy proxy here for the EMR SOX proxy, which is for AWS. And then you can run http ://ip10. In our case, it's 12 is our name node, 11 is our gateway node, and here we have to give 50070 so that we can access the name node web interface. And then you can see that you have 4 live nodes here, and then click on utilities, browse the file system, or the best way to validate whether there are any files on that is by running hdfs fsck command, or you can actually go to the underlying directory. Let me sudo as root here, sudo su -root, and our data directory is under Hadoop hdfs data. And if the files are already copied as part of the load balancing process from the existing nodes to this, you will find files over here. Right now there are no files. If you run this command on some other node like 15, which is another data node, So I'm going to the existing data node which was there before adding this node. So I'm doing a sudo su to root and cd Hadoop HDFS data, and if you run find dot minus name, you can see bunch of these things. So the redistribution does not happen. So the way you can force the redistribution is by running a command called Hadoop balancer, and this command needs to be run as HDFS. So you have to sudo su minus HDFS, because he is the owner of the Hadoop distributed file system in our setup. And now you can run Hadoop balancer, which will actually balance those files, or you can run HDFS balancer also. So the balancer will be running, means in a larger cluster, the balancer will be running for some time. Even though it came out immediately, now it has added the new instance, and it will slowly refresh all our blocks into those things. Okay, and you can see that as of now there are some configurations related to balancer, which I will be covering all those things in detail elsewhere. There are certain things which you can control so that your network traffic will not be saturated while the balancer is running, if you want to do it live. But there will be a separate video for balancer, and I will cover all those things in that. But one thing you need to keep in mind is, once you add new nodes to the cluster, you have to either run balancer or ensure it is balanced within a few days after adding the nodes to the cluster. That being said, let us validate again whether it have done any, it started copying any blocks to the new node. For that, again, you have to do root, sudo to root, and then you have to do cd to Hadoop HDFS data, and then you can run the find command which we have run earlier. Still the now the block is copied, so slowly the blocks will be copied onto this. This block is existing here also, so nothing have copied yet on this, but over time everything will be copied here. Actually the copy is going on. Earlier you have only one, but now you have two of those things. So the balancer is working. So that's how that's the end-to-end process of adding new host to the cluster. Let us recap. So first you have to provision the host, execute the prerequisites, copy repo files to use local repositories, add the host using wizard, use wizard to install the software, and then configure the host with the services desired. Configuration changes between the role of new host. Configuration changes between the role of new host. So if the configuration, if the new host is a master, you have to do one type of configuration. If the role of the new host is slave, you have to do different types of configuration. So you need to have the understanding of the architecture of the underlying service if you want to configure it as a master. And then validate the cluster. The best way to validate in this case is to use Ambari, and also to use name node web interface. And we have seen that even the new node is a live node now. And then run balancer, and you have to be careful when running balancer. You have to set thresholds so that it does not saturate the network. That being said, we have another topic on this, removing the hosts from the cluster, and it will be covered as part of the next video. Until then, if you have not subscribed to my channel yet, please do so. You will see a lot more content than just Hadoop or big data. And if you like the content of the video, please click on the like button. If you want to provide the feedback or add any question with respect to a particular video, please do so using comment section of the video. Thank you. Bye.